Hello everyone and welcome to the JavaScript Exchange, our fourth event overall, third virtual. I hope everyone is keeping well and can hear me okay. So I'm just going to give a quick intro over who we are and then we'll crack on with the talks. In case you weren't aware, the JavaScript Exchange is part of a larger meetup group, which is known as Docs or the Exchange Meetup. Currently, JavaScript Exchange is the newest addition to that. Just over 500 members now, so growing quite nicely and obviously looking to replicate the success that we've had elsewhere in the Docs world. In order to keep in touch with us, we have, of course, our meetup page, which is no doubt how you found us and joined us this evening. We also have our Twitter handle, which you can see there, JavaScript_EX, and also our LinkedIn page, which we regularly update with all the latest meetup news and future events. So this evening over the talks, we'll be running a Q&A function. So throughout any of the talks, you are more than welcome to chuck the panelists some questions based on what they're talking about. That can be viewed by anyone in the panel and will either be answered after their talk or can be answered via the chat function later on. So this evening we have two talks lined up. Firstly, we'll be going with Anna Maria over at Gousto, who will be talking us through how to boost React application performance with selectors. Moving on to then the guys over at Vortexa, JR and Seán. They'll be guiding us through pushing compute to the browser, how we've architected a data-intensive process on the client side rather than the server. Okay, I'm just going to hand you quickly over to Jess, my colleague here at JavaScript Exchange.
Hi, thanks, Tom. So just a little bit about background of us. Bear with me one moment. Sharing. Sorry for one moment, my screen is not sharing. Tom, you might have to take over on this because it's not actually sharing on Zoom, which is helpful.
No worries, sorry guys, I'll take back over. Minor technical difficulty there. So just as I was saying, the JavaScript Exchange, without the backing of our sponsors, Linux Recruit, would not be possible. Obviously, in normal times, we need to find hosts, speakers, someone to buy everyone pizzas and beers. And that is Linux Recruit. It's also coincidentally, obviously, where me and Jess work. Ignore the Linux part. We are full JavaScript. Obviously, I've spent years recruiting it, Jess as well. So if anyone's interested in a conversation, either looking or adding to your team, then feel free to reach out to the both of us. On top of that as well, if you are interested in becoming a speaker in any of our future events, obviously we're always looking out for new speakers to join us. Hopefully, in the not too distant future, we'll also be looking out for hosts as well. But yeah, if you'd like to do that, then please email us on that email there, info@linuxrecruit.co.uk, or just reach out directly. We're also very excited to announce our next JavaScript Exchange following this is in August. I believe it's on the 18th. Details will be coming soon. That's with Pento, Busu, and Ably as well. And then we've also got an interesting meetup with Kadiri, who we're partnering up with. Kadiri are a kind of coding challenge platform, which will be on the 26th of August. So without further ado, I'd like to hand over to our first speaker. Anna Maria, if you're there, do you want to take the reins?
Hello and welcome everyone here. Sorry. This should work. Okay, so tonight we will talk about how to boost our React application performance with selectors, and we'll focus on reselect. So before we start, I'm Anna Maria, and I'm a software developer in Gousto. I've been here for 2 years now, and here I learned like a lot, not just about performance and how important performance is, but also about like DevOps things, security and architecture principles. And all this was possible because we work quite cross-functional, and we work cross-functional not only in tech, but also with a food team and marketing and other teams. Before being a software engineer in Gousto, I've worked in IBM, where was also my first job in tech, and also had an opportunity to present at the meetup in my first 6 months, I think, in my career. So quite exciting. So what is Gousto? I'm sure some of you at least heard about Gousto. Gousto is a data-driven company that sells recipe boxes. We have at least 55 recipes on the menu each week, sometimes more, depends on the choice. From those 55 recipes, you can add in your box up to 4 recipes each week. And then our partner couriers will just bring the box with all the ingredients and the recipe card with cooking instruction to your door. And yeah, as I mentioned before, working cross-functionally actually helped me to understand how much is important that the website is performant, not only for our customers, but also for our company and for our tech team. So we will discuss today about why is performance important, what are selectors and reselect, why should we use selectors, and I'll give you a small quick overview of how we use selectors in Gousto. Let's start. So why is performance important? So from company point of view, bad performance means users will leave the website. No one really wants to see that loading state on the screen. Also, conversion will drop because users leave the website. That means the company will have to suffer from the revenue point of view. And there was a study that says, like 2 years back, that each second of waiting the website to load will lose at least 7% of traffic, and that's quite a lot. And also, if it's performant, your website is ranked, if it's less performant, will be ranked lower in the search engines. And also good performance means better user experience. But not only for company point of view, performance is important, but also from the developer's point of view. So it's easier to do local development because the application will be faster. Usually it's easier to understand the code. A performant code, from my experience, it's nicely wrote and you can actually understand what it's doing. It's modularized and all those things. Also, most of the time, better performance will be lower cost to host the application. And it's really important to have lower cost when you have a lot of services. And that's just me when I've seen that code that I wrote a few years ago. So what is this code about? Is just a short application that will just show some products and will group them based on the categories. And this is just one React component that will just get the categories and products from the state, from the Redux state, but all the other logic to actually filter the products based on that category that's selected, to filter the products based on a search string, also to show only categories that have actually products. All that logic was done in the component, in the React component. So let's see how the application actually works with all that code inside the React component. As you can see, it's a bit slow to just load the page because we need to do all the rendering there and on the logic. Also, as you can see, because of that logic, the state will update a few times. So the main component is practically the page. The header is those categories here, and the products is just this list. So all these 3 components are rendering 3 times just when you land on the page. And for who works with React, we know that React is super useful when it comes to understand what parts of the DOM to actually update. But when you put that to update 3 times the same part of the state, that can cost a lot. And this is a small application, but imagine a big one. So not only that that's rendered 3 times, also when you just change the category, so you'll need to render a different list of products, again, all those components will render again. And that's mainly because all the logic happens in the main component. That's the one that's parent to the whole page. When you will search in the products, again, all components will render again. And you can see that, again, that's quite a lot of updates on the DOM. And we don't really want to see that in a big application. This is a small one, so you'll probably not see that much. But how can we increase the performance of that application? So there are some main rules. We should add the data to the Redux, the one that we needed. We should move the logic outside the React component, so just handles UI changes with a set of data that will be received. We should connect each component that needs the data to store. So we avoid re-rendering all 3 components that we've seen in the example. But keeping everything in Redux state doesn't mean actually everything. We should keep just the minimum amount of properties. So all the computation of data, all the kind of filtering of data we want to do, we shouldn't really keep it in Redux state, because then our store will just increase. It'll be really hard to find something there. So how can we actually solve this problem? So in order to do that, we will need to talk about selectors. So what is a selector? It's a function that gets a Redux state as a parameter and returns a part of the state without transforming it. And this is called non-memoized selector, because all it does is just getting something from the state based on what you are telling it to do. So we have here a few examples. Get selected category. We'll just go to the state and get the selected category. So here you'll see practically what I have in the state for that application. I have products, I have categories, and I also have the search string. Why we talk about selector if they are just picking a piece of the state? So where is the performance improvement? But we haven't finished. So let's talk about reselect, and then let's put them together. So what is reselect? It's a library that allows us to create selectors that can compute derived data, allowing Redux to store the minimal possible state, are efficient. A selector is not recomputed unless one of the arguments changes, are composable. They can be used as inputs to other selectors. And I would like to just point you to this image on the corner. It's just like a child game. You just put together a circle as a triangle, and the reselect will just, output a square. So that's kind of the magic what reselect will do. So reselect will provide you this function create selector in order to create memoized selectors. If you want to read more about this, Redux official website has more details about this. But let's see how they actually help us with performance. So where should we use them? In order to do that, let's see this example. So where's my pointer? I'm hoping you can follow me. So as you can see at the top of this code, you will have some non-memoized selectors that will just pick something from the state. We'll have one memoized selector. And what that does is, if you look at that, I wish I can see my pointer. But if you look at that, sorry for, it's quite new to me to present on Zoom. That creates selector function will get as an input few methods. And in this case, we have just 2. Get products, that's a selector that will get products from the state, and get selected category, that's another selector that gets the selected category from the state. And you can see a third function, and that's called the result function. Where the products and select category parameter on that function comes from, they come from the functions above. So that's how create selector works. It's just getting all the functions you want to input in that at the top, and then the last one will be the result function that will get all the in the parameters all the results of the functions above. So you can use that. So I've used those to filter those products based on the category. At the product level, we had categories that that products belongs to. So I was just filtering and see if in those categories I can find the category that's selected. And then if you look at the next one, this is highlighting a compose selector. And you can see here that we've used as an input to this new selector, get filtered products. We used the previous selectors, the previous memoir selector, filtered products by category selector. And we add a new one that gets search string. And in that case, again, the result of those two functions will come in the result function as parameters, and we can do some more logic there. Now, what is important to know is the result of this selector will be cached until one of those inputs will change. So for example, if we look at the filter product by category selector, if the products in the state will change, or if the selected category in the state will change, that selector will run again and will do again the logic. But unless those change, that will not be called again. We'll just return you whenever you call it with the same parameters. We'll just return you that value that was already cached. And it's quite easy to just connect it to a component. So all we need to do is to connect the component to the Redux store. So just import the connect from React Redux and connect it with map state to props. And we call our selector passing in the state. And our, I'm going back 1 second, our create selector will practically get that state and just send it down to all the functions that are as input. So that's how those functions will get a state. So quite easy to just implement it, but let's see the result. So we have our new, just refreshed, our new page with selectors. And as you can see here, this main page, because now doesn't have any more logic, doesn't render more than once when just the first time when you land on the website. And then we have some, so create select categories filter, that's just filtering some categories. And then our product by category selector. That's the one that will calculate which are the products in the selected category. And then by search, because as you've seen, we composed that selector. So this is actually the one that we use in the application. And because this changed, this will change again. Oops. Sorry. So as you've seen, like we just called those selectors. Now, when we change category, because the category changed, that selector will be called again, and also the search. But what we will see is, in a second, also you see that only the products is rendered, not all three components. So that's a good point. And here you can see that when we search for product, because the category didn't change, that selector wasn't called again. So it was just calling the search one. That means that in order to recalculate the products in that category, we just use that cached value that we already have, and we just apply the search of the second selector. So that's kind of saving us some performance. And that's just a simple logic. So what we've seen in the video is that the main component, that's the page, doesn't render more than once. The product component is connected to the store, and that allows us to handle the logic in our selectors, and also just render just the product component when we do changes. Using selectors, we don't need to recalculate again the filter recipe by category when we do a search, so we save some computation time there. So this was just one selector and one like simple filter, but just imagine how you can save a lot of computation in other kind of scenarios. So I'm gonna go to just show you on the website how we use them in Gousto. I'm not allowed to show the code. So this is our Gousto website. You can select the delivery date, and based on the delivery date, we will have some recipes in collections. So it's quite similar to our example. And what you can see here is this collection, we have these recipes, and you can also see some details of the recipes. What we do is, because we also have some stock for that specific day, we need to show only the recipes that are in stock at the top of the page, and at the bottom, just the ones that are out of stock. So in order to do that, we will use selectors to just memorize the recipes in that specific collection that's selected. And then when we apply the stock sorting, so if it's in stock at the top of the list, if it's not at the bottom, we will just use that memoized state. So we don't need to do that every time when a change happens on this page. Also, if I'm going on, that would be memoized in the stage. So that's quite a lot of logic for us, because it involves stock and other kind of business logic behind. So it saves us probably half second to just render one collection. That's quite a lot. So as you can see here, again, when we change that, again, just showing the recipes from the category will memorize that state. And also, just in order to not send down properties to components, because that will mean a lot of renders, we'll connect, for example, this recipe card component, we call it, we'll connect it to Redux, and we just send an ID. And because that ID will not change, but maybe stock can change meanwhile, that component will just take the ID and will calculate based on the selector. So we have like one memory selector per component. So we will have like an instance of that selector. We will calculate the state, and we will just take from the state whatever properties we need to show on that component. This is our like detailed page. Again, the same principle. We are just sending the ID that is the ID that's needed for that recipe. And then all the other props, we take them from the state with selectors. So in this way, we don't send down properties in order to render too many components. And selectors are, like, I would say, a new thing to Gousto. It's like 2 years ago when I joined, we just introduced them. And for me, I didn't really understand why we do that, but it was quite cool because all the logic was in one place and it wasn't like just passed down to all of the components. So for developer point of view, it was quite cool. But then I start to understand how it's actually helping the application. And we improved our load time from, was like 6 seconds to just render the page with all the logic to, I think now it's like around 4. With all the logic that's involving all the calls to the backend and actually rendering the page to actually see it. So it's a huge improvement if you just use selectors and memorize the things that you know that will not change that often. So why should we use selectors? If you don't know by now, I don't know. So you've seen a lot of improvements just in that example application. But also, like, when do we need to think about selectors? Like, in which cases? So I just put together like 4 examples here. When you filter some set of data, like our search product, you don't want to recalculate all that logic before actually filtering those products. So you want to have that already calculated, and you should have probably put it in the state, because it will, as I said, that will just grow your Redux store. And sometimes it's good to put in Redux, but sometimes it's just going to grow the store, and passing down is not that helpful. So when you have that kind of situation, just use the select. When you have to sort some set of data, if you want the data to show in a different order, so as I give you the example of the stock recipes that on Gousto page, so the stock ones at the top and out of stock at the bottom. Again, because we don't want to recalculate all the logic for recipes that should show in that collection again and again, we just calculate that once and memorize it. When you need to combine some data, so as we had the product by category, in Gousto, again, we have recipes by the category. That's quite similar, but also recipes in basket, for example, which recipes are in our basket. Again, that's another example. And when you have different components that need the same set of data, but only one property change. So for example, in our example with product list, if we will have, for example, 2 product lists, that will just be, let's say, one will have the products that are, I don't know, under £3, and the other list will just have the rest of them. Because those products for that specific category will be memoized in that selector, we just need to apply the price limit in a different selector, and we can compose them. So again, that will save us some performance. And if you want to read more about this, beside the official documentation, I also found some to Stack Overflow explanation of that quite helped me a lot to understand how they actually work. Thank you. And I guess, where is my Zoom?
Yeah, thanks, Anna Maria. That was really, really great. Yeah, thank you. If any of our listeners, watchers, if you want to have any questions, feel free to pop them in the Q&A function, as I mentioned earlier, at the bottom of the Zoom application. But yeah, thank you very much. Without further ado, then I think I'll hand over to Vortexa, the guys. JR, Sean, are you there?
Hi, Tom. Thanks very much. Yes, we're here. Hopefully you can hear us okay. Let me just start by sharing my screen. Great, Tom. Well, thanks very much for the introduction. It's great to be speaking this evening. I'm JR Granell. I'm Head of Application Development at Vortexa, and I've also got along with me this evening Seán Berry, who's one of our senior developers. A little bit of background about myself. I've been working in building web-based applications, or using web technologies, for about 18 years now or so. Most recently, I've been using Node to help unify both the front end and the back end technologies, and obviously the power of browsers and JavaScript has really accelerated over the last 10 to 15 years. It's been pretty phenomenal. About 3 years ago, I got invited to join a little tech startup in a very cramped office by bank called Vortexa. And Vortexa have grown over the last 3 to 4 years to have offices in London, Houston, and Singapore. We are an energy intelligence company. And so what does that mean? We focus currently on tracking oil and products that are refined from oil. From coming out of the ground, it will go somewhere like Saudi Arabia, it will come out of the ground, it will go onto a vessel or a tanker. That'll head over to Singapore, where it gets refined into gasoline or diesel, and then it will go on to somewhere like the United States. And what we do is we track all of that. And we leverage the use of machine learning to track it at scale and provide not just real-time global coverage, but also historical coverage as well. Our customers use this information to understand flow of energy, and then they can introduce that into their sort of business decision-making. And our customers range from traders through to market analysts. It could be brokers, charterers, anyone within the energy industry, really. What we provide to them is what we call the Vortexa platform. And the platform itself is currently tracking around $2 trillion worth of cargo across the world. We track it by consuming and absorbing huge amounts of data from a lot of different data sources. So it could be direct feeds from satellites or terrestrial base stations. It might be customs data, port agent information, or from our industry partners that we work with. And the amount of data we're gathering, we have a core data set of around 170 billion data points, and we're streaming in about 110 million a day. So that's 1,200 messages a second, roughly. Now, we don't like to assume or determine how our customers query that data or get access to it. So we offer many different ways to slice and dice that data to be able to fit the needs that they have, because all the customers are different. And what we've built is a system that offers a near infinite combination of queries. And this offers some interesting challenges when we talk about performance and scale, which we'll do in a minute. It's important that performance is core to everything that we do. And actually, 70% of our queries all execute under 100 milliseconds, with our 95th percentile around 500 milliseconds. So as we grow, as we get even more data, we need to make sure that we're always performant and be able to deliver the data in a timely manner. Then we need to actually provide the information. And so the application development team is responsible for building the applications and the APIs that will query that data and the visualizations of those applications. We also support multiple distribution channels, such as AWS Data Exchange, and plugins for various programs, such as Microsoft Office. We also deliver custom and auxiliary services to deliver this data in a prepackaged way to certain customers and partners. So there's quite a lot of stuff that's going on there. And there's three really interesting engineering problems that this poses. The first one is about scale. And I don't just mean about the amount of data that's coming into the platform. I'm talking about engineering practices. How do you scale a code base? Do you keep it as a monorepo or monolith? How do you scale an engineering team from one person up to 10, 20, 40, 50? There's obviously infrastructure issues, and they all need to scale as well. So this means you need to think about your architecture. How stateless is your architecture, and how do you ensure it scales in an automated, performant way? Performance is key. They want to be able to ingest the data and get the data into the hands of the users as quickly as possible, and you can't afford latency and lag. Then finally, we need to provide a frictionless experience for the customers, right? Because typically they will start with a very broad data set and then want to perform surgical queries to get exactly the information that they want in order to answer their decision. And through that whole process, it needs to be very easy to use. Now, I could probably spend all day talking about our architecture and our tech stack, but what I really briefly wanted to talk about is some of the languages that we use within engineering at Vortexa. So all of our APIs are built in Node, and all of our applications are built in React using the React.js stack. Anything that's written in JavaScript is actually TypeScript. So our whole estate is written in TypeScript, and that really helps when we want to maintain the constructs and the schemas between data coming in and out of different systems. In addition, we also use Python and Rust within the engineering department, as well as Java and Scala, particularly for data engineering tasks. So how does this all come together? Well, it's all powered by the Node APIs and the JavaScript and the React platform. And I'm going to show a screen grab that I took earlier. What this is showing is a subset of the vessels that we're currently tracking. Now, this is a map, and I'm just scrolling out here, and it's showing around 10,000 vessels in real time on the map. It's a little bit confusing. It's a lot of information going on there. So what we can do is we can drill down this information really quickly. And this video is at 1x speed. I haven't increased it. So all these queries are being performed on the browser. It's going back to the API and back again in order to get the information that we want. And we can drill down to a specific vessel and see information about that vessel, where it's been. And we also have a route prediction service that allows us to see the vessel route that it's likely to take. This kind of view is fantastic for those who are interested in what's happening right now in a live way. But for many analysts, they want to be looking at a historical analysis as well. And they do this in order to see things like historical change, particularly at the aggregated level. So everything on the screen you can see here is clickable. And that means you can cut the data however you want. And in this case, I'm just simply looking at crude exports coming out of Saudi Arabia, heading into the United States for a particular 3 months in order to understand the change of flow for that region. Now, this is a very brief introduction. And what I want to do now is hand over to Seán, who's going to talk about one of our problems. Now, this is a very typical issue to have in any kind of SaaS application where you need to just export stuff. But what we wanted to do is to actually use the power of JavaScript and actually use everything that comes with a modern browser to perhaps evolve how you may traditionally approach this kind of a problem. What I want to do now is hand over to Seán.
Hey everyone. So in our team, an engineer is generally responsible for delivering a project from start to finish. Today, I'm going to walk you through an example of that process using a problem that we've solved as part of building our platform. Am I able to switch slides here? No, I'm not. JR, can you? There we go, cool. So when we set out to build something or to solve a problem, the steps that we take are typically we analyze the problem. So we have to pay really close attention to the requirements. Then we have, JR generally asks us to offer 2 to 3 solutions with pros and cons. So this helps us to avoid tunnel vision and a situation where we only focus on one specific solution before we jump into the code. And then finally, we have the actual implementation. So we really want to consider the architecture and the tools that we're using. So what's the challenge? Well, in our platform, we have a table of cargo movements. These rows of data show information about the movement of cargo around the world. We've been asked to implement a button that, when clicked, will download a CSV of the entire data set to the user's device. Now, whilst this doesn't sound too bad, there are some details to consider. So first of all, the table is using lazy loading. So there's actually only 50 rows to begin with, as opposed to the 108,000 you can see in the screenshot. That's not all there and available in the client. Secondly, the API is limited to returning 500 records at a time for performance reasons. And it's also really important that users are able to continue to use the platform without any interruption when the download is in process. The data that you see here is being updated in real time, although we don't really need to worry about retrospectively updating any rows that have changed since the download began. As long as the download finishes in a reasonable amount of time, that should be sufficient. We also want the users to be able to choose which columns that they're exporting into the CSV. And after having an analysis of the telemetry and some user behavior, and holding some discussions with the analysts who work at Vortexa and some of our clients, we've determined that being able to download in the region of 800,000 rows is an acceptable target. And this would represent about 1 gigabyte of data. So with a task like this, there are immediately two obvious solutions that stand out. The first is building this on the server side, and the second is obviously building it on the client side. Let's take a look at how we might implement this on the server side. So some of the pros of doing that would be that the export is happening on our system, so we have total control over it. We don't have the unknowns of what platform or what architecture the export is going to be running in. We can also optimize the delivery of the data. We can use tools like server-side caching, or we could deliver pre-made CSVs for some common export parameters. We can also rely on auto-scaling to handle increased loads. And unlike a client-side implementation, we shouldn't really need to worry about network instability or lost requests, in theory. If we look at some of the cons for the server side, well, with a server-side implementation, to handle scale, you might have to implement some sort of a queuing system. You also have to come up with some sort of strategy to handle retries. And depending on the implementation that you go for, there may be some additional points of failure that are introduced. So for example, you might have a transactional mail service, or you could have a file storage system like S3, which you need to upload documents to. And then you've got your queuing system and your retry logic, which could all be additional points of failure. Then you have to deal with latency. How does latency react with real-time data in terms of a queuing system? If an export goes into a queuing system and it takes 30 minutes to happen, and the data has changed in that time, how do you deal with that? And lastly, what about cancellation? If a user just closes a tab and leaves the page, do you want to continue to deliver the document to them via email? Or are you going to let the server churn away on some ghost client that doesn't exist anymore? So why don't we look at the client-side implementation? The pros of the client side are that at this point in time, we actually don't have any requirement to deliver the data at a later date. So if the client closes the tab mid-download, the export will cancel automatically, and this is perfect for our requirements. If you have any failed requests due to network issues, it's really easy to implement retry logic for them on the client. The key concern with the client-side implementation is having a reliable and scalable API, because the API can then remain totally stateless. And this means it can scale to the size of your infrastructure or to the size of your wallet. So in terms of cons for the client side, speed may be a bit slower than server side because you're dealing with network latency. And this network latency will be multiplied by the number of requests that you make. So the bigger the data set, the more network latency that you're going to have. Downloading lots of data client side means you're going to be consuming a lot of memory because it's going to be all the data stored in memory, and this could cause you some issues. And what about if you cause lag to the application and it becomes less responsive and less usable? And how do you deal with browsers like IE11? So this pretty much says it all about IE11. So with all of that said, we've analyzed the pros and cons of both of our potential options, and we've kind of studied them and worked out how we can mitigate them based on our existing infrastructure and our specific requirements. So in terms of a scalable API, well, our API is completely stateless and it's deployed in Kubernetes. So if it gets hammered with loads and loads of requests, it's going to automatically scale horizontally and blast our AWS budget. We don't need to worry about lots of users exporting data at once because K8 will increase the number of pods and the load will be evenly distributed across all of these. In terms of network latency, we're using HTTP2, so we can take advantage of things like multiplexing and header compression to mitigate this. Multiplexing, for those of you who don't know, essentially allows the browser to request multiple files in one connection and concurrently. So you reduce the number of SSL handshakes that take place, and you don't have to receive the assets synchronously. So what about memory issues? Well, modern browsers are pretty good with memory, so this is a reduced risk. But while we're building this, we're going to keep memory in mind and try to be as efficient as possible. In terms of lag and lack of responsiveness, we can mitigate side effects in the application by siloing our export in a web worker. And surprisingly, IE11 supports web workers, but we stopped supporting IE11 in January 2020, so this isn't actually something we need to worry about anymore. So let's look at the actual implementation and break down the tools that we've used. The first thing that happens when the user clicks the export button is that we spin up a web worker. We all know that JavaScript is single-threaded and it uses an event loop. So anything you do in the main thread will affect the UI. Web workers are a tool that allow us to utilize a new thread to be used in the background. So the main thread that the platform is running on can continue unaffected by the export process. Workers can run pretty much whatever code you actually want them to run. There are some limitations. They can't directly manipulate the DOM or use some of the methods and properties of the window object, but they can communicate with the main thread using a system of messages. So these are sent using a post message method, and they can be responded to using an on-message event handler. Using this system of messages, we can pass information between the main thread and the web worker. For example, how many records have been fetched, and then the main thread can use that to show a progress bar, for example. So web workers have pretty good support. We've got an image here that shows the can I use. It shows that they're supported in pretty much all major browsers, including IE11, as mentioned earlier. But I'm going to show you a demo now of how useful a web worker can be. So on the screen is a really simple demonstration. Hopefully the frame rate of this hasn't decreased due to being on Zoom, but the demonstration has an animated circle, which is bouncing from side to side. And what happens is I've created a loop that's going to increment a variable by the value of 1, but it's going to run 1 billion times before printing the value on the screen. So obviously this loop, it's going to take a couple of seconds to execute. Now the button on the left will invoke this loop in the main thread, whereas the button on the right will spin up a web worker to invoke this loop. You can see that when the loop is invoked in the main thread, the animation actually stops. This is because everything in this thread is now blocked by the loop. If this was your web app, it would be completely unresponsive for a couple of seconds. Nothing the user does will do anything. The loop that is running the web worker on the other side has absolutely no effect on the animation. And once the hard work of running this loop 1 billion times is over, the web worker just sends the result back to the main thread to insert into the DOM, and it works flawlessly. So if you guys have any expensive operations happening on the client side of your platform and you aren't using web workers, I fully recommend that you guys check them out. The next thing I'm going to talk about is data fetching. So we've spun up our web worker and we need to get the data for the export. To facilitate this process at Vortexa, we've built an internal SDK for consuming our own API. So what it does is it adds a layer of abstraction and it makes the process of getting data quickly way easier for us. When we make a request through the SDK, the endpoint that we're querying will return the total number of documents. So in this case, cargo movements that match our query. The SDK will then automatically paginate these requests to the API until it has fetched the full collection of documents. So we are using a queue handler to simultaneously resolve 3 promises at a time. Each promise makes the same request, but increments the offset by default chunks of 500. So this process will continue in the background until all of the data has been fetched from the API. The browser actually allows us to make up to 6 concurrent requests at a time to the same domain name, but we've chosen 3 so that there are 3 free slots essentially available for the user to still use the application while the export is happening. This way that if they're browsing and it's still using the application, it's not going to be affected and slowed down by the fact that all of the available requests are being used by the export. So I'm going to show you what the network tools looks like when this download is happening. This is it. This is, you can see the simultaneous requests are being made. So as it starts, the little cog that you see to the left of the endpoint name, it indicates that a request is being made by a web worker. And if for whatever reason any of these requests fail, they'll actually be retried at the end of the process. And if successful, they'll be, the data from them will be included in the CSV. So one of the last things that I want to cover in our client-side export implementation is state management. So in our platform, we use Redux. This is just an implementation detail. You can use pretty much any library, local storage or session storage, or even things like MobX. With careful state management, we can craft an export UX for users that looks awesome. So the export can happen in the background while they continue to use the application, but they can check progress whenever they want. We can also queue multiple exports that will run sequentially and ensure that the user sees a notification as soon as the export is complete. So I'm just going to show you a demonstration of what an export within Vortexa looks like. The web worker is handling all of the logic in the background. It's making all the requests to the API. It's applying any transformations, and it's creating the CSV file. And all it's doing is using the messaging system to pass basically the progress back to the UI and when it's been complete. And we allow users to minify these alerts or cancel exports, and they'll also see when the notification, when the export is complete, they'll get a notification. So as a summary of this implementation, this works really well for us based on our specific requirements and our current infrastructure. Generally, all of the users using our application are desktop-based and they have a good internet connection. Like an airplane taking off, we're not actually using full power. I mentioned earlier, we've only got 3 parallel requests at a time running for our exports. We could increase this to 4 or 5, and we could also half the size of the paginated chunks coming from the API if we wanted a performance boost. But these sort of things are factors that we can just tweak to find what we think is a reasonable time for exports to happen in. Recently, I've been checking our telemetry, and I can see many examples of users having downloaded CSVs of around 350,000 rows, and it's only taken 7 or 8 minutes, which seems perfectly acceptable for our requirements. In terms of any future improvements to this process, well, we're looking forward to some really exciting developments in the ecosystem. We're thinking about how to maintain a quick and awesome experience for our users, especially in the face of a data set that's growing not only in complexity, but also in size. So one of the exciting APIs that we're currently looking at is part of the Google Capabilities project. It's the native file system API. And this will allow us to build powerful web apps that interact with files on the user's local device. So once you've granted an access to the web app, we will be able to actually read or save changes directly to files and folders on your device. And in combination with this, we can use something like the Node Streams API. With these two combined, we can create a file on your device and stream the data from the API directly into it as it arrives. So this means that we won't be storing all of the data in memory, and the solution should scale a lot better as our data set grows in size, which it inevitably will. Another optimization that we could make is currently we're returning all of the raw data and we're applying a transformation to it in the web worker to put it into the shape that the customer has requested. And this is something we could move to the API if we wanted to. In summary, I hope that this has been informative for you. I hope you've learned something. We're doing some super cool stuff at Vortexa, and this is just an example of a typical engineering problem that we'd encounter on a weekly basis. I'm going to quickly pass you back to JR, and he's going to finish up the presentation, and then I think we'll be super happy to answer any questions that you've got. Thanks.
Thanks, Sean. Really interesting. What I want to just highlight is that we've got a blog on Medium. It's our Vortex blog. and I would definitely check it out. If these kind of engineering problems are of interest, we tackle other things such as how to do satellite object detection and some real magic by the boffins at Vortexa who get involved in that. It would also be remiss of me if I didn't mention hiring. We've got a couple of senior positions open. What I would say is that full stack engineering position that's on the screen there, we actually have positions for junior, mid and senior level full stack engineers. So if you're interested or you know someone who is interested, it's been a particularly difficult time during lockdown for many people, particularly within the software industry. We've been particularly lucky at Vortexa to not only be continuing to hire, but actually increase our hiring plan and hiring schedule. So please do get in touch. Other than that, thank you very much for the opportunity to speak this evening, and we'll be happy to answer any questions that you may have. Thanks.
Cheers, guys. That was really interesting stuff. We've had a few questions come through on the Q&A function. I'm not sure if you can both see that at the bottom of your Zoom. The first one that I've got here from Barry is, which API is used for the tracking?
Sorry, I'm just trying to pull open the Q&A here. My mouse is going mental on my Mac. So which API is used for tracking? We have a couple of different APIs. So we get a lot of data from a lot of different data sources. AIS signals, for example, is a key data source that we use. We don't expose that AIS data directly, but we do have derived information from it. We expose that information through our API. Our API is designed to be consumed by not just our own applications. We don't build APIs specific to our applications either. So we dog feed our own system. Our applications use that, our outbound services use that, our customers use the API as well. But we don't provide any third-party APIs, if that's what the question relates to.
Great stuff, thank you. Second question we've got here as well is, given the total download size is roughly 1 gigabyte, if I remember correctly, where is the data results being saved per request, local/session storage merged at the end?
Yeah, so that was the example. Sorry, Sean, do you want to take this one? Actually, you built it.
Sure. So the web worker obviously is running this operation, and it's gathering the data in memory. So it's not going into local or session storage. It's just the memory that's allocated to the web worker, which is quite a large amount actually in modern browsers like Chrome. And then it's being merged at the end, and the CSV file is being created, and it's prompted to download at that point. So we do have to consider, as the data set grows, how this will scale. And that's why we're looking forward to using things like the native file system API and also node streams, so we can get rid of that requirement to hold it all in memory. And also, if our requirements were to change drastically, we could also look at other implementations of this functionality. But at this point in time, this works really well for us. So it's what we've gone with.
Thanks, Sean. And then last question that I see here is from Sam. So noticed a lot of vessel activity in Southeast Asia. He's wondering, does this affect on the amount of users and type of users based in Southeast Asia?
Not particularly. There are a number of major hubs around the world that, funnily enough, are similar to our office locations. So Houston, London, and Singapore. There's no detrimental impact from users from those perspectives. There will be network latency often. Most of our servers are dotted around the place, so depending on where you are, the network latency that you have from your internet connection to the edge of the cloud provider will make a difference. But we scale pretty well, and whether you have a huge surge in Singapore or Houston, bearing in mind you have time zone differences as well, so we do see multiple spikes per day as people log in. It's actually pretty well distributed throughout the day.
Great, brilliant. Thanks, JR. Sean, thank you as well. Great talk, guys. If that's everything, I think that about wraps us up. I'd just like to take the chance. Yeah, thank you both, Sean and JR, for that talk. Anna Maria earlier as well. Really interesting stuff. Our next event is, well, we've got a couple actually in August. So details will be released via the meetup page tomorrow. I think one is the 18th and the other is 26th from memory. So yeah, thank you everyone for tuning in. Thank you for the speakers, and we'll see you soon.